In this video, I want to find the integral from -1 to 1 of the integral from arccosine y to pi of sine x times the square root of 1 plus sine squared x dx dy. The first thing to do is to rewrite the order of integration, and we're going to do that by looking at the graph. So x starts from arccosine y to x equals pi. If I solve for y, I get y is equal to cosine x. And so the left bound is x equals arccosine y, so that would just be the cosine graph. And the right bound is x equals pi. So that's what we have here. In red is our cosine, in blue is our pi. So that's bounded. And then y goes from -1 to 1. So we start -1 and then we stop at 1. And so now we're going to change the order. So we're going to go dy dx. So y, the first thing that for y is the top is going to be y equals 1. And the bottom is just going to be y equals cosine x. So that's what we have here. And then the x limit, we start from x equals 0, and then we end up at x equals pi. And so now we can integrate this. So the first thing to do is integrate with respect to y. Sine x times the square root of 1 plus sine squared x. That's a constant. So when I take the antiderivative, I just put a y next to it. But first, actually, before I do that, I'm going to rewrite this. So sine squared is 1 minus cosine squared. And so 1 plus sine squared becomes 2 minus cosine squared. So I'm doing this because it's going to make the math easy. And so integrating that, again, the inside is just a constant when you're integrating with respect to y. So we put a y, and then we're going from cosine x to 1. So I kind of skipped a couple steps. You get that. And then you want to integrate this from 0 to pi. And this one requires u substitution. So you let u equal cosine x, du is negative sine x dx. So now when x is 0, u is 1. Right, cosine 0 is 1. And then when x is pi, cosine pi is -1. So our limits become -1 to, or 1 to -1. And then sine x dx is just negative du, and that's why I have the negative outside. The square root becomes square root of 2 minus u squared. And then we'll multiply that by 1 minus u. So now we can distribute the square root and break this up into two separate integrals. And also notice that I flipped the limit here. So it was going from 1 to -1, and when I do -1 to 1, this negative goes away. So that's why there's no negative in front. And so I could just integrate this now. So the first integral, this one I'm just using a integration table. Otherwise you would have to use trig substitution. So anyways, you get this, and then we're going from -1 to 1. So you get 1 plus pi over 2 for that. And then the second integral, notice that this is an odd function, because if I plug in a negative u for u, it just becomes negative of that entire thing. And it is symmetric. It's over a symmetric interval because -1 to 1, just think of it as from 0 it's 1 to the left, 1 to the right. So it's symmetric. And when you have that, the area is going to be 0 because the left side is going to cancel out with the right side. So really we only care about the first integral, which is just 1 plus pi over 2. And that's going to be the final answer.